Hi dear friends. So let me continue my series of lecture on the first unit, heat and mass transfer conduction. So in this session we are going to see a numerical problem on the area of lumped heat analysis. As I taught in the class, so lumped heat analysis means sudden exposure to the heat to the ambience. Sudden heat exposure to the ambience. So before going to the numerical problem, I would like to share some information on the content which I shared how to access the heat and mass transfer data book. So in the heat and mass transfer data book, the page number 57, we can notice that there is a lumped parameters analysis system. In that lumped analysis system, we can notice that body with high thermal conductivity suddenly exposed to the convective atmosphere. So there is a equation for HL by Ks which is less than 0.1, which is correlation and validity. And here T minus T infinitive and T naught minus T infinitive, which is equal to exponential of minus Hs divided by C V rho to tau, which is nothing but exponential of mathematical simplification minus Biot number multiplied by F4 number. We should know what is that means H, average convective heat transfer coefficient on the solid surface. L is significant length, V by AS, V is volume, A is its surface area, K is its thermal conductivity of solid, tau is time, tau C is time of constant in second, T naught initial temperature of solid, T infinity surrounding temperature, T is temperature of solid at a time, B is Biot number which is HL by K, which is for solid Ks, F equal to Fourier number alpha T by L square, Q instantaneous heat flow rate, Qt total heat flow up to time T tau. So these all are the parameters involved in this equation. So we know that T minus T infinity divided by T naught minus T infinity equal to 1 by E, where tau C, which is nothing but time constant E, which is equal to CPV divided by HAS, Q equal to HA T minus T infinitive, AS is nothing but surface area, T which is equal to temperature of solid, T infinitive equal to surrounding fluid temperature, Qt equal to rho C V T minus T naught. So this is what the data we should know before getting into the numerical problem. This we have seen in numericals as a derivation part in our lumped heat analysis also. Again I am repeating, lumped heat analysis is nothing but sudden heat exposure to a ambience. So now let us get into the numerical problem. This is a numerical problem. A copper cylinder 10 cm diameter and 50 cm long is removed from a liquid nitrogen bath at minus 196 degrees centigrade and exposed to room temperature at 30 degrees centigrade, neglecting internal temperature gradient. Find the time taken by the cylinder to attain a temperature of 0 degree centigrade with the following assumptions. Surface heat transfer coefficient, which is equal to 30 watts per meter square minus K. Density of the copper cylinder, which is equal to 8800 kg per meter square. Specific heat of the cylinder, which is equal to 0.38 kilojoules per kilogram Kelvin. Thermal conductivity of the cylinder, which is equal to 350 watts per meter Kelvin. Now let me know the given data, whatever written is written here, D, L, K, rho, Cp, Tt, Ti, T infinitive, and we have to find time to attain 0 degree centigrade. So this is the cylinder through which the fluid is flowing, the liquid nitrogen, the volume, area of cross section and effective length and T infinitive, everything is given. Analysis, we know that volume equal to pi by 4 d squared into L, area equal to pi by 4 d squared. So this is cross section area plus pi dl, the effective length equal to volume by area. So Biot number, as we seen in the HMT data book, HL by Ks, so that we repeating HL by K. Biot number is substituted here. We found the value of Biot number which is less than 0.1 as per HM data book. The description is the value is only for the less than 1. When we substitute less than 1, we have to use that formula t minus t infinitive, ti minus t infinitive. We substitute in the right side exponential of minus ha rho c pv into t. We substitute this value. We get is 2.14 10 power minus 3. And when we substitute, we get the value time which is equal to 1.18 hours. So this is what the problem. Hope you understood. Thank you very much.